Okay, so 3-4 concavity and second derivative test. We're going to add another step to what we've been doing. I will show you examples, and you will do everything we're doing on every problem, regardless of what the directions say. Got me? Okay, so what we are doing in examples is what you're doing. So we have the concavity. When I look at this, what does it tell me? It says let f be a function, blah, blah, blah. It's continuous over interval. Happens all the time, right? It says if what? What does this say right here? Second derivative of x is greater than 0. It is concaved what? Up. That means it opens what direction? Up. If the second derivative is less than 0, meaning it is negative, it concaves what? Down. So that's what you need to get out of that. And see how this concaves down? If there are x values at which the function is not continuous, these values should be used as well. So we're going to find the zeros. We're going to plug in, not zeros, sorry. We're going to plug into our second derivative. And we're going to make intervals today with our second derivative as well. And we've already talked about undefined numbers being numbers we have to put in our intervals as well, haven't we? So just puts this in there again, that anything undefined is going to be used as well. It's just a reminder. Okay, are we good? No. Hopefully you're not writing everything. Gentry, please put your phone down.
It's on the table.
What are you messing with? Your watch? Then stop.
Yeah, I was going to text my boss to see if I worked today.
Okay, but we need to focus.
I don't know if I got approved or not. Kind of need to know.
Okay. So the next thing, I'm just hitting you with all the rules because I want to do examples on the paper. Okay. Point of inflection. Point of inflection is just where it changes. It switches concavity. Okay. I'm concave down. Do you see that? And then I concave what? Up. So this point right here would be a what? Point of inflection. It's concave up and it switches to concave down, so it is called a what? Point of inflection. P of I. Concave up, concave down, so we have a P of I. Now the reason why you have these two different things, look at their tangent lines. The first one, what kind of a tangent line hits that point? What kind of a line is this blue?
Vertical.
Horizontal? Yes?
Wait, which one?
This one right here.
Oh, I thought you were talking about the last
No, the first one. Okay, first one's horizontal. The second one is just a positive slope, yes? Okay.
Vertical.
Now the third one is a vertical. The third one is a vertical. So can I have tangent lines with different slopes? My first slope is 0, yes? My slope is positive. And my slope is undefined. Okay, note a graph crosses its tangent line at the point of inflection. That's all see how it's crossing it? That's what they wanted to show you. Am I good? Okay, oops, it jumped. Okay, this is the second derivative test. And I hit it and it's going to go back. Go back. The second derivative test. We are going to notice this in other things. Remember what?
Where'd theorem 3.8 go? Or is there not one?
I probably just didn't want to put it on there.
Okay.
Let me look. I maybe just decided it was kind of unnecessary. Because if I think what it was just, it was the point of, 3.8 was the point of inflection.
Okay.
They made it look harder than it was. Okay, so this is a second derivative test. Okay, second derivative test tells me relative min or max. We know that when it changes from increasing to decreasing, that's a max, yes? And when it changes from decreasing to increasing, that is a what? Minimum? Mm-hmm. So we will already be looking at that, but a second derivative test is just to back us up. Got it? Mm-hmm. So if the second derivative is greater than 0 at some constant, so when we do our interval analysis, then it is a relative what? Min. It's opposite. If the second derivative is less than 0, then it's a relative max. If the second derivative equals 0, the test fails, and you cannot tell. You have to go back to the first derivative with the increasing, decreasing. You have no second backup. Got it? Mm-hmm. Okay. So second derivative test just looks for what? Mins and max? Yeah. And it's opposite. If it's greater than 0, then it's a min. If it's less than 0, it's a max. And the pictures are just I could look, if on my sheet it said decreasing to increasing, then it is a minimum, right? Mm-hmm. Increasing to decreasing, it is a max. So we will run the second derivative test, but it's just to corroborate what we're already getting. Let me know when you got that done, and we've got all of our vocab done, and we're ready for examples.
So we need a lot of paper to do these problems.
Yes. Yes. If you want to get blank paper, you're more than welcome to get blank paper and use it on these problems, because we are going to be adding more stuff starting tomorrow. Okay? Tomorrow is going to be our last step. We're going to be talking about horizontal asymptotes. What happens going to negative and positive infinity. Okay? And then tomorrow we will be graphing. We'll be starting to graph. We will graph Tuesday, Wednesday, Thursday, Friday, Monday, and our test will be Tuesday.
Wait, see, blank paper like this, or no line?
Either one you would like to use. It doesn't matter.
We'll be using the same paper tomorrow?
What I'm saying is you can use the blank paper if you want, if you don't want to mess with lines.
Can I sharpen my pencil? Is it
Yep.
easier without lines?
My brain gets out of I can put more on a paper with no lines myself. Okay.
Where's that at?
Bottom.
Right here?
Yep. And if it doesn't have holes, I can punch holes in it.
How many examples are there?
3 to 4.
Did anyone else want some? I picked up. Oh, thank you.
Okay. Let me get my camera up. You need to start at the top of a page. Do not try to squish. Do not try to squish. Your brain will get squished and it will all fall apart. Okay, so f of x.
Are you recording this?
Yes.
Okay.
F of x equals 6 over x squared plus 3. Can you all see that okay?
Mm-hmm.
Do I need to? Did that help? Make it worse?
Help.
Okay. So the first thing we're going to start focusing on, or starting with today, is the domain. Because I've now brought up twice that excluded values also need to be in our intervals, haven't I? So we need to find the domain, and this is a rational number, so anything that makes this denominator 0 is not going to be in my domain, correct? Mm-hmm. So I have to set my denominator equal to what?
0.
0. So x squared plus 3 equals 0. So then x squared equals negative 3. Square root, what's the problem with what I'm doing right now?
Because you can't find the square root of a negative.
I cannot find the real square root of a negative, correct? So is there anything that's going to make the denominator 0? No. And if I would have looked at it, it's x squared plus. So that's not subtraction, so it's not going to do it anyway, right? So my domain is what then? All real numbers. So x such that x is instead of all real numbers. So we're going to add domain today. And if we had a number that's excluded, then we would put that into our intervals. Okay? So then we're going to go with the first derivative test. You see how I'm labeling. Starting tomorrow, we will be doing x-intercepts, y-intercepts, vertical asymptotes, horizontal asymptote, first derivative test, second derivative test, and our chart. So we're going to put everything together that we've all done. So, derivative of this, you guys find it, and I'll find it. I'll give you time to start. Okay, so did you get negative 12x divided by x squared plus 3 quantity squared? Okay, so I need to get my critical numbers now. How do I find my critical numbers?
Set it equal to 0.
Set it equal to 0. So I'm labeling my work as I do this. Now, when I set this equal to 0, do I need to be worried at all about the denominator? No. Because when I multiply the denominator over by 0, I'm still going to get 0. So I get 0 equals negative 12x. So x equals what?
0.
0. Okay, so the first derivative test, remember, what?
0 equals a negative 12x. Wouldn't it be 12? X equals 12?
Wouldn't you divide by negative 12? And 0 divided by negative 12 is...
Oh, yeah.
Okay. So the first derivative test that we'll use that for can tell me increasing, decreasing. Yes? Okay, so now we're going to do the second derivative. So it's important that I make sure my first derivative is correct. So my second derivative, I get to do the quotient rule again, don't I? Remember, you're looking at your first derivative.
Wait, wouldn't it be to the 4th?
Oh, yes, it would be. Okay, so here is where it's important because I remember I said you need to simplify it to where it's easy to plug in numbers, right? We also need to simplify it where it's easy to solve for it. Okay, so let's see. I could factor out a negative 12, couldn't I? Everyone see that? Negative 12, negative 12. And I can also factor out an x squared plus 3 to what? Just the first. Okay.
Wait, why did you write negative 2?
Yeah, why did you write
Oh,
negative?
because I just forgot my 1.
I'm so confused right now.
Why?
I don't know how you're.
I have a negative 12 right here, yes? Do I have a 12 right here?
Yeah, but isn't that
Okay.
subtraction?
Well, it's subtract all this multiplied.
Yeah.
Okay, so it's fine. Because these are two different, this is one term and this is another term. And I can also take out x squared plus 3 to the first. So this is just stuff we've been doing.
I've never done that.
We have done this.
Not reduced like that.
Yes, we have.
I'd rather
Okay, Maddie,
apply it all up.
Maddie, we cannot multiply all that out. Okay, so when I divide negative 12 by negative 12, I get 1. When I divide x squared plus 3 squared by x squared plus 3, I still have what?
2.
X squared plus 3. I still have one of them left. Now I have a negative 12 divided by negative 12. That's a 1, so this is reduced out. I factored out my x squared plus 2. Yes? So what do I have left?
2x squared.
2x and 2x,
Should be 4x squared.
and it's minus, so minus 4x squared. All over x squared plus 3 to the 4th. So in here, I've got negative 3x squared plus 3, right? If I combine like terms.
Uh-huh.
Okay. I can reduce one of my x plus 3's, can't I? Is there something I can bring out of negative 3x squared plus 3?
The 3.
Can I bring out the negative with it?
Yeah.
Yeah. So negative 3 times negative 12 is what?
36.
So I have 36. And I would be left with x squared minus 1 over x squared plus 3 cubed.
Wait, minus 1. Where'd you get minus 1 in?
Because positive 3 divided by negative 3, because we factored out this negative 3, right? Changes the sign. Now do you see why I said it was so important to get our derivatives down good? So, from there, I need to set that equal to 0 again. So when I set it equal to 0, do I need to worry about the denominator?
No.
No, because 0 times the denominator times 0 is still what? 0. So I get 36 x squared minus 1. Well, what is 0 divided by 36?
0.
So 0 equals x squared minus 1. So x equals
1.
and
0.
1 and negative 1. Because you would add 1 over, and when I take the square root, isn't it positive and negative?
Mm-hmm.
Okay. So, I'm going to make my intervals with anything excluded from my domain. Was anything excluded from my domain?
No.
No. My critical numbers and the zeros of the second derivative. So I didn't give you an interval, so where does my interval start?
Negative 1. Negative infinity.
Negative infinity. Thank you. So I have my intervals. I have my x's. I have my f of x. We're going to plug it into the original function. Some of them. I have my f prime of x, which is my first derivative, yes. And I have my f what? Double prime of x? and I have my conclusion. So I'm going to start at negative infinity. And what's my first value I need to look at? What? Negative 1. Okay, and then I'm going to write negative 1 on the x, on the second line. I put negative infinity to negative 1, and then I put x is negative 1. Where did that negative 1 come from?
The critical number.
Not the critical number. It came from the second derivative. Critical numbers are the first derivative. It came from my second derivative, so I'm going to write that it came from my second derivative so I remember where it came from.
And the interval part?
Yeah, just because there's no interval, because I just have x. Because the interval is negative infinity to negative 1, and then I have x. And then the next line is negative 1 to what?
Why wouldn't you write negative 1 like up more?
Because negative 1 is not between negative infinity and negative 1. Like, negative 1 is a point where things change. Okay, so negative 1 to what?
Positive.
Nope, to 0. Okay, we're looking at critical numbers. Zeros are the second derivative, and anything excluded from the domain. So the next number we have is 0. And then we're going to put second line down, next line, 0. And where did 0 come from?
That's derivative 1.
Okay, first derivative, which is a critical number. So I leave 0 and go to where?
To 1.
To 1. And then I put 1 the next line down, and that came from the second derivative. And then I leave 1 and go to where? Positive infinity. Okay, so now that we have our intervals, we're ready to go through this. Yes?
Why do you have it like the 0 with critical numbers but not the first derivative?
Because the zeros of the first derivative are critical numbers. Like, that's what their name is. The second derivative doesn't have a name. Okay, so I need a number between negative infinity and negative 1.
Negative 2.
Okay. I used negative 3. Okay, so negative 2. Now I did put an f of x. We might as well plug it in there. So f of x means I'm plugging it into what?
The original.
The original. So I would get 6, yes,
Yeah.
in the numerator. And if I plugged in negative 2 in the denominator, negative 2 squared is 4 plus 3 is 7. So that tells me the graph is positive in that interval, doesn't it? Is it not? Yeah. If it was a nice number, then I could maybe put it on my graph, but I'm not putting 7/6 on my graph. How about you guys? No. Not unless I had to. Okay, now I got to put negative 2 into what?
The first derivative.
The first derivative. So now all I care about is the signs. So I'm coming up to the first derivative. This is a negative, yes? So I have negative for the negative 12. And I plug the negative 2 in here. I'm going to get a what? Negative. I plug negative 2 in the denominator. Well, it's going to square, so it's going to be what? Negative 2 squared is going to be positive or negative?
Positive.
Positive, so the whole denominator is going to be positive, yes?
Yeah.
So I have a negative times a negative over a positive, so the whole thing is what?
Positive.
Positive.
So why didn't we do that for the first one? For for FX?
Because I was hoping it was something that we could actually put in the graph. Okay? So then we gotta put it in where now?
And the second derivative.
Second derivative. So 36 is positive,
Yeah.
so there's a plus. When I put negative 2 into x squared minus 1, am I going to positive or negative?
Positive.
Okay? And then I have negative 2 squared is going to be what?
Positive.
Positive. Then cube it, it's all going to be what?
Positive.
So I get a
Positive.
positive. Okay, so we're going to go through here. F of x tells me since it is positive, it means the graph is positive, yes?
Mm-hmm.
So it's positive, parenthesis. What does the first derivative tell me when it's positive? What is the graph doing?
Goes up.
Okay, it's increasing. I just put INCR. And what does the second derivative tell me?
Increasing.
Nope. We just went over it. What's second derivative tell me?
Second.
Second derivative is positive.
Relative
It's
minimum.
concave.
It's the opposite, so it's decreasing.
No,
Minimum.
look at your notes, please. When the second derivative is positive, this is an interval. The second derivative test is on an actual number. This is the interval. When the interval is positive, it is concave up. It's the first thing you wrote down. Concavity. Okay? So, this interval tells me that between negative infinity and negative 1, it's positive, meaning it's above the x-axis. Yes? It's increasing, and it's concave what way? Up. So the bowl's open.
Why'd you write convey?
Oh, I don't know. I was trying to get you guys to remember. Up.
Doesn't it
I don't know. Yeah, why am I wanting to put a Y in it? It's an E. Just can't spell today. Okay, so that's the interval. Intervals tell me that. Now I'm going to plug in the second derivative. I'm going to plug it into f of x. Maybe it's going to be a nice number. With negative 1, it's probably going to be a nice number, isn't it? Something I could put on my graph. So plug it into your f of x. See what you get.
2. 6 over.
Oh, you get 6 over 4. So you get 3 halves. We could graph 3 halves. That wouldn't be too bad, would it? If I needed to. Okay, we're not going to put it in the first derivative because it's not going to tell me anything. But at a second derivative, could it be a min or a max? Could be, right? So if you put it in the second derivative, 36 is always positive, correct?
Mm-hmm.
But then you get 1 minus 1, so you get what?
0.
0?
So we positive.
No, 0's. What happens when I take a positive times 0?
Turns into 0.
It gives me 0. And what did it say when I got 0 on the second derivative? Did it tell me anything? No, it didn't tell me anything. I'm not going to write anything on the decision yet because I don't know anything. So I need between negative 1 and 0.
Negative 1/2.
Negative 1/2. I don't want to plug negative 1/2 into the first, do you? No. We could do positive, negative. We'll do that. So if I plug it into the first, 6 is always positive, right? 1/2 squared, negative 1/2 squared is still going to be positive. So this graph is still positive, isn't it? Okay. So plug it into the first derivative. I wish I could have it all up there, but if I do, you can't see. So negative 12 is negative, right? Times negative 1/2 over, and my whole denominator is going to be what?
Positive.
positive, so the whole thing is positive. Now I'm going to plug it into the second derivative. So 36 is positive. Negative 1/2. Well, negative 1/2 squared would be 1/4, and 1/4 minus 1 would still, it'd be negative, wouldn't it? And then the denominator would be positive, because everything's squared, right? So what's it going to end up being? Negative. So this line going across tells me that's positive, correct? It's what? Increasing. And I want it. And it is concave. Now, at negative infinity to negative 1, it was concave up. Negative 1 to 0, it's concave down. So what does that make 1? Not an asymptote, it was in your notes today. When it switches from concave, point of inflection. So sometimes we'll go through our intervals and go back to our points and decide what they are. Actually, not sometimes, a lot of time. Okay, so then I got 0 as a critical number. So plug 0 into f of x. What do you get?
632.
So you get 2. Okay. And we're not going to do first derivative. Oh, wait. Yes, because it's a critical number. Oh, no, it's a number. It's actual number. Sorry. So I need to plug it into my second derivative for my second derivative test. What?
Why do you skip that one?
Because it's not an interval. It's just a value. Like 0 is a critical number. It's not an interval. So it only does me good on f of x and then the second derivative test. Okay, so when I plug in 0 to the second derivative, I get positive times a what? Negative. See that, Riley?
Yeah.
Okay, over a positive. So the whole thing is a negative. Now, the second derivative test says if it is less than 0, then it should be a relative max. Okay? It should be a relative maximum. So this means if this is increasing, my next interval better show that it's what? If it's increasing for it to be a max, it needs to then do what? Decrease. So my next one, if I don't get it decreasing, something went wrong, correct? Okay, so 0 to 1, give me a number. Half? Okay, so if we plug half into f of x, the numerator is positive, the denominator is positive, so the whole thing is positive. First derivative, negative 12 times positive half over a positive, so the whole thing is negative. And then into the second derivative, so positive, and this is where we got to keep our brain straight because 1/2 squared is 1/4, and 1/4 minus 1 is a negative. Okay. If you need a scratch paper off to the side, but I don't care about the numbers, just positive, negative, that's it. Okay. And then the denominator is still going to be what? Positive, so the whole thing is negative. So going across, it tells me it's positive, decreasing, and concave down. Now, Is this the relative maximum then at x equals 0?
Yes.
Because it's increasing, decreasing. Now, could it also be a point of inflection? Yeah, but it's not, is it? Concave down, concave down. So you're going across and comparing things. Okay? So, f of 1. So if we plug in 1 to f of x, I think we get 3 over 2 again, don't we? The same as negative 1?
Yeah.
Yep. Okay. I'm not going to plug it in to the first derivative because it's not a critical number. This is why it's important to tell yourself where it came from. Does that make sense? That it's not an interval. So the second derivative test says if I throw it in, right? So throw it into your second derivative. So 36 is positive. The quantity would be what? 0 over a positive, so the whole thing is 0. So that doesn't tell me anything, right? Well, it could be. We don't know. So now we go from 1 to positive infinity. You guys want to do positive 2? Okay, so if we plugged in positive 2, I'm assuming we get 6/7 again, wouldn't we? Okay. In the first derivative, we would get a negative times a positive over a positive, so I get a negative. In the second, what do I get? Times a positive over a positive, so I get a positive. So go across to make your conclusions. So it's positive, decreasing,
Concave up.
and concave up. And you can put con up. I thought, well, maybe today I should write them out, right?
The other one is a point of inflection.
So this one is also a point of inflection.
Can you draw with that graph a little bit?
Yep.
Is this all we're doing?
Today. Like, this is what you're doing today. Okay? That's why you don't have very many problems. Okay, so my graph here, I'm going to add some stuff that I know.
Do we need to draw the graph on the assignment?
No. Starting tomorrow, you will, because you'll go through everything. I don't have any vertical asymptotes. I do have a horizontal asymptote. And we'll review how we find that tomorrow at 0. Well, we had the point of 0, 2, so that would be a y-intercept, wouldn't it? Wouldn't 0, 2 be a y-intercept? What is the x value at every y-intercept, guys? 0.
Yes.
So 0, 2.
Where'd you get that?
I got it right here. And tomorrow we will specifically find the y-intercept when we start. Okay? So then I know, I'm trying to get both of these up here. I know between at -1 and 3/2, it's a point of inflection from concaving up to concaving what? Down. So -1 and 3/2 would be 1.5, wouldn't it? So right here, I'm not going to put a big point, but I'm going to put a point. And then I also know at 1 and 3/2, I have the same thing happening, don't I? Yes?
Mm-hmm.
Okay. So it's going to, and it's all positive. We saw that. So it's going to go along here, concaving up. Then it's going to switch to concaving down. Be concaving down. And then switch to concaving what? Up. So when you draw these graphs, do you have to make sure I can see your concavity? Yes. So when we did this last year, we kind of just drew this bump. We didn't know where this happened. Now do we have the ability to figure out where it happened at? Yes. Okay, should we do a ration, another one?
We have 4 minutes.
Hmm?
We have 4 minutes.
We have 4 minutes. We can start it. We'll do this one. Okay, f of x equals x to the 4th minus 4x cubed. So this is not a rational function. It is not a square root. It is not an exponential. So what's my domain? Is there anything that can make it undefined? Nope.
How do you know that?
Because it's not a rational number. It has no variable in the denominator. It doesn't have a square root. We're good to go. First thing we do is what? First derivative test. 4x cubed minus 12x squared. So I found the zeros. I'm going to factor 4x squared out. How about you guys? And x minus 3. So my critical numbers are x equals 0 and 3. So what do I do next? Okay. This one's going quicker because the derivatives are easier, right? I get 12x squared minus 24x. How about you guys? Okay. And then I set it equal to 0. I'm going to factor out a 12x. And that gives me what? X minus 2. So my second derivative numbers are going to be x equals what?
0 and 2.
0 and 2. So I look at my domain, which I'm going to have any excluded values?
No.
Nope. I look here and I look here. So I'm going to start at negative infinity and go to where? To where?
0.
0. Trying to kind of go quick. And then I'm going to put 0 here in my x column, correct? And then 0 to what?
Um, 2.
And then I put 2 in my x column. And 2 to what?
3.
3. And then I put what over here?
3.
3. Oh, this 0 was a critical number and a second derivative, yes? I forgot that. This 2 was from the second derivative,
Yeah.
and the 3 was a critical number,
Yep.
and then 3 to where?
Infinity. Positive infinity.
And I would go through and do the first derivative, f of x, first derivative, second derivative, and then make it what? Make sense?
Kind of.
Okay, so remember that on that second derivative, like here, you're not going to do the first, but you are going to do a second derivative test. Every problem, what are you doing?
Same thing.
Same thing. Hardest part is going to be making sure you get your derivatives right, isn't it?